Hi, welcome to another Coding Thursday series with Fixitgearware Security. Last week's episode, we discussed about operators in C programming, and these operators we described were categorized into three. The first being the unary, the second being the binary, and the third being the ternary operators. As part of the building blocks in coding, these operators makes it easy in writing clean codes that saves computing memory and provides code readability. Also, on last week's episode, we demonstrated the binary arithmetic operation with a basic code example, and these codes we are reading using two methods and approach. So if you're yet to see that video, kindly check the description below. For this week's episode, we're going to demonstrate the unary operator, which is categorized into two distinct categories. The first being the increment, and the second being the decrement unary operator. So without wasting much of your time, let's dive into the description of these two unary operators. Unary operators are operators that negates the value of its operand. These operands are numbers, which comes before or after the unary operator, depending on its variation. There are two types of unary operators. The first being pre-variation or prefix, and the second being post-variation or postfix. For the pre-variation, in a prefix or pre-operator, the operand number is either incremented or decremented before it is retrieved for its computation. The second unary operation or operator is the post-variation. So for the post-variation or the postfix operator, the operand number is first retrieved, then the computation, either increment or decrement, is now then conducted. To further make this explanation more clear and concise, let's fire up our online GDB tool to demonstrate this code. We'll remove this. Okay, so let's declare a data type integer. And let's assign this data type a variable name. So we call it Fixit. And let's initialize this variable name to a value number of, let's say 6. And we, of course, terminate our program with a semicolon in C programming. Now, we want to perform the unary operation prefix. So what do? We say, okay, now we want to print the prefix value, using the prefix unary operator. And of course, we have to specify the data type, %d for integer, and we make this a spacing using /t. And we call the variable name here, which is Fixit, right? So now, since we are doing the prefix, this number here that was assigned to the variable name Fixit would first be computed. Then the value will now be stored to the memory allocation or memory allocated to this variable name, which is, of course, Fixit, right? So now, when we print this using the printf statement, right? Instead of the output being the value 6, we put the prefix here, right? Which is the increment. So prefix means this comes before the variable name. When we print this right now, instead of the output being the value 6, what the terminal or the program will be displaying back to us, the user, will be 7. In the sense that it first performs the action of a unary prefix operator. Then after this operation has been completed, it stores this value to the memory allocated to this variable name. So when we now call the print statement, the new value that has been computed is what will be displayed to us instead of the initialized value, which is 6. So if we run this right now, we should be getting the number 7. As you can see here, we got the number 7, which of course indicating that we are using the unary prefix operator. For the prefix operator, the value assigned to the variable or operand is first incremented, of course, which is this number, or decremented depending on what operator we are using. So the two types of operator, decrement, and this is for increment. Let's comment this out. So basically what it's trying to say is that for the prefix first, right, the value assigned to the variable or operand, of course, this is the operand, which is also the variable name, is first incremented or decremented depending on the operator we're using, which is this or this. Then after this value has been incremented, it's now stored as the new value. It's now stored as the new value to the variable name. Then once we call this in a print statement, right, the new value is now then printed out. The new value is then now printed out to us or by the program. And of course, if we also negate this pre-negation, right, and we run this program, instead of having 6 right now output to us, what the program will be displaying to us is the value 5. So what does this mean? First, before the program does anything, it decrements the initialized value by 1. After it has finished conducting the decrement computation, it's then now stores it in the memory allocated to this variable name. So when we now call this print statement, instead of the first initialized value of 6, we'll be getting the output to be 5. So if we run this program right now, in this case, we are using the decrement, right? And we'll get the number 5. Let's remove this. Now, let's say we want to print the postfix, right? Sorry about this. We'll say printf. We want to print the postfix. So what do? Say, okay, /t, %d, specifier, and we'll say fixit, variable name, and we'll say ++. Now, for the postfix, what is done is that the value assigned to the variable name is first stored in the memory allocated to that variable name. And when we call that variable name, that value that is stored is then printed out to us. After the value has been printed out to us, it is now incremented by 1 and stored back in the memory allocated to that variable name as the new value. So if we run this right now, following the concept of postfix, right? The number that was assigned to Fixit is 6, right? So when we now run this program, the number that is going to be output to us back is now 6, because the concept of postfix is first to store the value, then print it out before computing the value. So if we run this right now, we'll be having the value 6. Whereas for prefix, we'll be having the value 7. And if also do the decrement instead of the increment, right? For the postfix, we'll still be having the value, of course, 6. We'll run this right now, and you can still see we still have the value 6. Because for postfix, the value is first stored in the allocated memory or memory location assigned to the variable name. The stored value is then printed back to us via the front end of the program or the terminal. Then this value that is now printed is now incremented by 1 and now stored back to the variable name or to the memory allocated to that variable name as the new value. And when we now call the program for the second time, the new value will now become the incremented value that has been computed during the first approach. Whereas for the prefix, when we assign the variable name value, it first computes the value, then stores it. So when we call it for the first time, it does no computation. It just displays to us the new value that was computed previously. Then that value becomes the new value of the variable name. So to make you understand this whole jargons right now, let's iterate this value over a for loop. So instead of initializing Fixit, let's just declare Fixit, right? Then we'll say for loop. We'll say the for loop should be Fixit should start with the value 1 and of course semicolon. Then we'll say Fixit less than or equal to 4, or let's say 5, semicolon, right? Then of course we open bracket, close bracket. So within this for loop will now be the rest of our code. So we can say printf, the first network value, so you understand what's going on. The first network traffic value S. So what do we do right now? We'll say, okay, %d, and we remove this, right? And of course, it's printf. Sorry, sometimes it feels like I'm writing Python codes. So we say printf, right? Now, what we did here is that on code line 14, we declared a data type integer, and we assigned this data type a variable name called Fixit, right? So we want to iterate over a range of values for Fixit, right? We now initiated the for loop. Then we say Fixit should start from the value 1. And as long as Fixit has not exceeded or is equal to 5, then whatever that is in this for loop should be printed out to us, the user of the program, or whatever packets computation we are doing. So what happens right now? We have initialized Fixit to be 1, right? It's for you to understand the prefix right now. So the prefix, what the prefix will do is to pick this 1. Let's write a comment here. The prefix will put 1, pick the Fixit, right? Equals to 1, right? And add additional 1 to it. Then print out to us 2. So instead of this to be the first network traffic is 1, right? We'll be having the first network traffic will be 2. And if we run this program right now, then after that, it's going to increase the 2, right? 2 plus 1, and it will display 3. So it will continue this until this loop is conducted 5 times. So as long as this loop has not completed the 5 loop statements, so the program or this code in this loop will continue running until the command has been fulfilled. And let's make this in a new line so we do not make our program so messy. And if we run this right now, the first network traffic value is 2, 3, 4, 5, 6. And as you can see, this loop is conducted 5 times, right? 1, 2, 3, 4, 5. Now, this is exactly how the prefix works. So the prefix first does the computation, and the new value stored to that variable name will become the new value using that computation. If we use the postfix right now in this program, instead of starting with 2, it will start with 1. So for postfix, remember when we described postfix, it first picks that value that was initialized and store it in the memory allocated to that variable name. And when we call that variable name, it prints that number out first, then does the computational increment or decrement, depending on what operator we are using on the operand, which is the variable name. So if we run this right now, it's still going to be 5 loops, and it will be the right value of 1, 2, 3, 4, 5. Unlike the prefix that started with 2, 3, 4, 5, then ended with 6. So if we run this right now, you can see we have 1, 2, 3, 4, 5. So this is how the postfix works. The postfix does this, and at the end of the day, we have the actual value. Now, remember sometime we wrote an article on botnet on our website. You check it out also. You visit fixitgearware.com. We stated something about amplified attack. Amplified attack, right? These attacks involves the threat actor, right? Making a series of small packet requests. And when the botnet replies to this request, the responses are amplified and redirected to the victim's server. Now, you might ask, how does this Unary operation helps in botnet? Let's say we want to accept this as an input from the user who is using this botnet, right? So remember in C, we use the scanf to read numbers and store them, right? And we say, okay, specifier is %d for integer data type, right? And of course, using the & sign to read the address of the variable name. And we, of course, terminate our program with a semicolon. So now let's say we print F. This request right now, we want to output the value, right? We say the packet you requested is 2. This is the echo reply. So we just put D and we do %D specifier and we say, okay, fix it right. Now, in this case, we now use the prefix, not the postfix right now. Here, let's print this. Okay, let's now print a new line, in a new line. And here we also print. So each time this loop is conducted, print it in the new line and run the semicolon. So here we initialize the variable name to be 1 as the packet request we want to make. So this sequence will become a serial number of 1, 2, 3, 4, 5. Let's call it a series of requests we make, which of course is a 5 request, right? Then these values are read by the remote, or infested hardware or computers of the various devices that were infected by our master botnet. So when we now run this program, we enter the value 1, right? The prefix will now say, hey, I received 2 packets from you and I'm replying back to you with 2 packets. Whereas in the real sense, what we supplied is a value of 1, but to the remote computer or the botnet, what is saying that we sent to it is 2. So if we run this right now, let's say we run this and we say, okay, let's stop this. Let's make this to look like we're making a request. Let's make this like we're making a request. Sorry about that. Just for you to understand what's actually how these botnet traffics are computed. So enter the first network traffic value number. So we just want to have a serial. That's why the %D or the specifier comes before the tab to make it look much beautiful. So when we run this right now, it tells us please enter the network traffic value number 1. So if we enter 1 right now, since we're using the postfix approach, you can see the serial, the first initialization is 1, right? But when this number is now read from the user and sent to the botnet, the response, which of course is the output that is going to be given back to us, since we use the prefix here, will now become 2. So it will tell us that, hey, I got 2 packets from you and I'm replying you with 2 packets. But in the real sense, what we supply to the, we used a minimum request and the response is now amplified. So when you hit enter right now, it says the packet you requested is 2. This is the echo reply, right? We can stop this. We can say, okay, let's say the echo reply. Let's say the echo reply, right? The echo reply to the packet requested is, so let's run this program again. Now we enter the value 1, right? And it tells us the echo reply to the packet requested is 2. So basically what this program is saying that we enter the number 2, which in the real sense here, we just enter the number 1. And if we enter the number 2, right? It will now do the computational value of 2 plus 1 and tells us we requested 3 packets, right? So you can say the echo reply to the packet requested is 3. So what this master botnet is getting from us is not what is given out. So we are making a series of packet requests using low values, but the response that is being sent back to the target or the victim machine is amplified. So basically, this is how Unary operators are used in performing amplified attack, flooding a victim server with a series of botnet traffic. And we also have crafted a way for you to easily understand these operators. And these 2 simple ways are, for the Unary prefix operator, right? The operator comes before the variable name. For the Unary prefix operator, the operator comes before the variable name. Whereas for the postfix Unary operator, the variable name comes before the operator. So this here, right here, is the postfix. And this right here is just what we described, the prefix. So for the prefix, right, this is the comment. And for the postfix, this is the comment here. Also, for the prefix, the value assigned to the variable name is first incremented then stored. And when these values are called via a print statement, the new value stored during the computation becomes our output value. So that's for the prefix, right? So let's say we gave 1, right, to the variable name. It does 1 plus 1, 2, and now stores this 2 to fix it. And when we print fix it, instead of getting 1, we are given the number we're given, or having the number to display it back to us. Whereas for the postfix, when we assign a value to the variable name, the value is stored, and when we call the variable name, the number is fed back to us. The number is fed back to us and computed and stored back again to the memory assigned to the variable name or allocated to the variable name. So it's very easy. It's very simple trying to understand this increment using the prefix and postfix, or decrement using the prefix or postfix. Unary operators are very good if you're writing a tool in cybersecurity, or if you want to develop or build tools in cybersecurity. Not everything requires you to write, a robust code. Like we just did here, you can see we just wrote just 4 lines of code. 5 lines of code, including the for loop, right? And if we include the variable name that was initialized, makes it 6 lines of code. Whereas if we are not using this for loop, or we did not use the unary operator, then definitely we will now require to write for each steps. We say, okay, enter the first number or network traffic value of 1, read the value, then we also request again for 2, 3. So by the time we are done writing this lines of code, since it's 5, so we multiply it by 2, right? Plus this 2, we'll be having like 12 lines of code. Whereas with this method right now, we just have only 1, 2, 3, 4, 5, and 6. So unary operators are very good. You should learn them. And when we start writing other tools or codes still in C, we'll be able to understand the beauty of these unary operators, especially when we use them in the ternary arithmetic operations, where we'll be using the for loop, then involves the double end comparing two values, or using the OR operand, and so on. So we have finally come to an end of today's episode, and we hope you learned something new. If there are other ways you think we can make this content better, kindly leave your comments below in the comment section. And also do not forget to give us the goodies, which are the likes, by tapping that thumbs up button, subscribe by also hitting that subscribe button, and turn on the notification bell to get notified when we drop another episode on coding with Fixitgearware Security. You can also reach out to us and connect with us on our various social media channels displayed on screen here. And also you can check the description below to get the links of our various social media channels. And this keeps getting better as we intend on making this known first using our free demos on C programming before we publish our paid courses. So be at alert anytime soon before the mid of the year. Our C programming course will be dropping, and we'll be sharing the links. So that's it for this week. Thank you for watching, and we hope to see you next week on another episode of Coding with Fixitgearware Security. Bye for now.